Bit of a tangent video. This will probably go in the extras channel because it'll be short, maybe. But for another video, I was testing out these two lithium-ion V-mount batteries, and I went to charge them with my Keithley battery simulator slash tester, and it started overheating. Don't know why that is. It might be just an issue with the fan. Hopefully no big deal. Problem is, in the meantime, I have no way of measuring the charge power over time, like to get watt hours or amp hours that go into these batteries. Well, I should say no convenient way. I do have a way to test the discharge, which I was using a Rigol, forgot the model number, I'll put it on screen, for discharging, but I realized it would be handy to have an interface to tap into a USB-C cable, or a pair of cables in this case, and be able to use this BK Precision 5335B, which is a power meter, but it has a couple of binding posts for the current and a couple of banana jacks for the voltage. So the question was, how do I get a USB-C cable to connect to that? Numerous ways around that particular problem. In this case, what I'm going to do is, alright, and what I have are two of these. These are both obviously PCBs. They're just breakout boards. They've got USB-C connectors on one end, and then all the pins from that USB-C connector broken out into through holes. The idea being, I'm going to interconnect these two, layer them on top of each other, put pin headers between them, except for I was going to say VCC, but VBus. And VBus will be broken out for the current path, and I'm going to tap VBus and ground for the voltage monitoring. This isn't necessarily ideal for this purpose because, of course, you should monitor the current and voltage as close as possible to, in this case, the battery that we're discharging, so we can see how much current is actually coming out of the battery, because there will be losses in the cabling, and any losses between this device and the battery, or this device and the subsequent meter and the battery, are not going to be reflected in the battery's power consumption, because those will just be dissipated as heat. But in the scale we're talking about, I don't need an hyper accurate view into the power consumption of the battery, so I don't think those losses will be significant in the grand scheme of things. Need, oh crap, 4 pins there, and same on the other side. And I'm just using yellow for fun, because I kind of like how it goes with blue. It doesn't have any deeper meaning. Then we've got another 4, and then 3. And of course, I just got to make sure I line up. Yes, these are just going to sit right on top of each other so that all the pins line up, because this is just going to be a through connector otherwise. Okay, so that one's going to be the top, and let me put the longer pins through that. Mistake! And now in USB-C there are 4 pins for voltage, or for positive voltage. So 4 of these pins are labeled VBus, and 4 pins are labeled ground. In devices, those will always be tied together, and maybe even in cables too. And that's really just to increase the current handling capability and provide redundancy for the current path. And I'm not going to be soldering both sides of this yet, because I have to put cables in here to tap off those connectors, but I am going to solder on this side. And the only reason I have the bottom board in there is so that I make sure the pins stay aligned while I solder. Alright, there we go. And so now we need to loop VCC out from one of these and then connect it to the other end. And I'm going to see if I can route the wires in between the two boards before I solder them together. Although, I mean, there should be enough clearance in there. And for the current path, I'm going to be using 14 gauge blue wire, because then for the voltage monitoring, I'm going to be using red and black wire. Probably don't have to use this heavy a gauge, but it's really just for durability, so I don't have thin wires hanging off this thing. And I also want this wire to be relatively long, which again, is not necessarily a good thing, because the longer the wire is, the more resistance and the more energy gets dissipated in the wire. But because it's a relatively heavy gauge for the amperage that we'll be dealing with, I mean, for example, in this test, it's going to be 3 amps max that's going to be flowing through this cable, or this wire. So we want it to at least be able to come around the back of this unit and then to the front, and then to sit on the bench in front of the unit with the wire perhaps going around the side, one side or the other. So I want it to be reasonably long. So I'm going to go with maybe 20 centimeters, and then just a little bit longer because I can always cut it down. So the reason I mentioned before that the VBus pins are tied together is because that's what I'm going to be doing with this wire. Obviously, each of these through holes is not going to take a 14 gauge wire. So I got a couple of options. I could just use smaller gauge wire and then splice it onto this. But what I'm going to do is just strip this back, fan out the strands, twist them together, a little bit of heat shrink tubing. Although I don't think there's anything they can really... yeah, you know what? There's nothing they can short out on inside of here. As long as I keep the bare wire away from any... Well, let's see how it lays out. Kind of winging this as usual. I'm not going to count strands, but let's see if this bundle will fit. That might be slightly too thick. No, I think once I trim it down, it'll be fine. Maybe I should have counted conductors. That might be too thick. Okay, I'm going to take a couple of strands off of this. Okay, and then, like I said, I want this to be on the opposite side. So if these boards are going to be like this one's going to wind up on the right side of this board, so this one's got to be on the left. But I got to make sure I leave clearance for the pin headers, so I can have to bend the wires over and away. Well, it looks good. And obviously I still need to insulate this, but I just want to test fit, make sure the wires don't interfere with each other, and then we can still get these two halves together. Yeah, it's going to be tight. I mean, I should have left the longer pins on this side. I don't know what I was thinking, but it'll be doable. I was wondering why this electrical tape was so crappy. Like, the adhesive is not very good, and the adhesive was coming off on the roll. And then I realized this is not Scotch brand 3M tape, which it's some, I don't know, no-name brand. It doesn't even say. So this is actual Scotch electrical tape. My favorite, personally, in my opinion, it has the best quality adhesive of all the tapes, of all the electrical tapes that I've tried anyway. If anyone knows of a really good electrical tape that's maybe better, or that I should try, let me know, because I am a fan of electrical tape. And being USB-C, this is going to deal with, well, I was going to say 20 volts max, but really I guess right now 28 volts max. So I'm not concerned about the breakdown of this insulation. I'm more concerned about something poking through it. And causing a short, although it's also not safety critical in this case, because if these two wires short to each other, that's just going to short the VBus to VBus, and it won't actually create any kind of hazard or even any kind of real problem, other than I won't be able to properly measure with the attached device, with the attached meter. Now, of course, with the electrical tape in there, it makes the clearances even worse. But if I compress it down a little bit, it will go together. Rodent. Okay, well, not the most elegant process. And there is just a little bit of a gap there where the pins are. I should have put the longer pins on this side. That was just dumb. But the reason I left the pins long on this side is because I was going to tap the voltage monitoring off a couple of those and then route those cables between the pins coming out. And then I just gotta trim the wires that went through. And now, just to test, we should not have continuity right now between these two wires. No. Good. And then we should not have continuity between these wires and any other pins other than VCC. That wire is actually connected on this side, I think. Whoop. I gotta clean the desk off. That's VCC. Good. We only have continuity between this wire and the VCC pins. And just check the other side. Alright, cool. And then before we do end up with a short, let me just clean all this off. Aside from him being my namesake, or me being his namesake, I've always been more of a Scotty type of engineer. I hesitate to call myself an engineer, but you know what I mean, than a Geordie. I feel like Geordie was like well organized, knew what he was doing at all times, you know, had everything on lockdown. Whereas Scotty was, you know, sort of like, whatever, Captain. I can't do the accent, but you know what I mean. He was more fly by the seat of his pants. I always like Next Gen more than TOS. Yeah, we don't need all the strands here anyway. And I always felt like I understood the character of Geordie better than Scotty, because I think he was more developed in the show anyway. So I kind of like Geordie better. I'm just saying that I associate my style more with Scotty. I should have left one of these wires long so I could just splice onto it for the VCC, but live and learn. Like I said, this is just sort of an approximate learning experience here, because I've never made this exact thing before, so I don't really know what I'm doing, if you couldn't tell. This one I will tin and then bend at 90 degrees. Should I brighten that image up a little bit? Yeah, I probably should. And then I'm going to tack that to that VBus pin right there. I mean, at least the shitty pink electrical tape does work as a pair of helping hands, more or less. Well, it's kind of sloppy. I just kind of flooded the solder in. But as long as we're not touching that pin next door, we should be fine. Now, we've got no continuity there. And let me just do a quick visual inspection much closer to my eye. Oh yeah, those are not touching. Although I would feel better with slightly less blobby solder there. Yeah, that's got good clearance around it. And then before I wrap this whole thing up, what I'm going to do is just tie the VBus conductors together, grab a USB-C power supply, plug one into here, hope it doesn't blow up. It didn't blow up. And then we'll use one of these batteries as a test, and we should at least see that it is, well, that was a fuck up. I didn't take into account that these USB-C ports were going to be spaced out properly. Alright, I'll pick this up tomorrow. It's already getting late. Alright, well, that was last night. Let me get back to it tonight. I got a little frustrated, to be honest. That was a dumb mistake, and I just didn't feel like desoldering the whole thing. But that's what I'm going to have to do, because there should be enough space to get two connectors in there if I bring this board up to the top of those pins. At least that's my hope. So get the old desoldery-do back out, and yeah, fun. I mean, it's my own fault for not planning this, you know what I mean? Oh, and I actually cut one of those pins down already. So that's not even gonna work. Yeah, I'm gonna have to desolder it completely. Yeah, alright, so let me pop these two wires back off. Then hopefully I'll be able to leave these blue wires intact, because that was kind of a pain in the ass last time. There we go. Just took a little bit of cajoling. So now, yeah, I cut a couple of these pins short because they were just getting a little close to one of the wires that I was tacking onto the top. And then this time, let me actually check this to see if I can get 2 connectors in there, because if these are going to have to be spaced out even more, I don't think I have, ultra long pin headers. I don't mind if they're a little tight to each other, but oh yeah, I mean, that'll work fine clearance-wise. And actually, now I'm thinking, since I'm going to have extra clearance in there, maybe I could squeeze the red and the black wires in there as well. So that'll make it a little neater, I suppose. In fact, what I can do is, rather than a pin header connecting 2 of the VBus pins and 2 of the ground pins, I can make the same hassle for myself that I did before. Oh, I can't use it with the VBus pins because those are already occupied, but I can tack this, I can split this and tack it down to a couple of different VBus wires. And then for the ground, I can interpose this in between 2 ground pins. Okay. Again, not the prettiest thing, but it'll be covered by electrical tape and out of the way. So, and then we'll do the same thing, well, similar thing with the ground. I'll come into this ground pin since it's open anyway. It's the second one from the top. So that's going to also be the second one from the top here. So we're going to have to use 2 pins and 1 pin surrounding the ground. Okay, so 10 strands to fit through the hole, although I'm going to tin these ahead of time, so I might go with 8. And then just to keep the pins in alignment while I solder, let me just put these back together. Yeah, there we go. Oh, almost. There we go. Okay. Well, that pin's a little twisted, but hey, whatever. Electrically, it'll still be fine. Then this will take the place of another pin. Just need a bend in it like that. Yeah, that should work. It's not super stiff, but I'll just have to get that lined up first and then push the rest of the board down. So there we got the 2 halves. Yeah, and then we got the pins poking out the top, and just double check. Yeah, okay. Okay. Hopefully now this is done. Let's get a quick continuity, or rather lack of continuity check going. I'm actually going to tie these together just so all my VBus pins are tied together. And I'm going to test from VBus to every other connection, especially the ones right adjacent to the VBus connection. Oh, that's another VBus. That's correct. Scared me for a second. I thought I messed something up there. That's another VBus. Sorry, I know you guys really can't see what's going on, but let me bring this down like that. That's another VBus. Okay, good. And then let's check ground continuity from my phony baloney ground connection to the end of this wire here. Yeah, it's just I'm not really on it, but yeah, we got continuity there, and make sure the other side has continuity. Yep. And then as far as our red wire goes, that should actually tie to VBus. Oh, only VBus on one end or the other. So if I got both VBuses together, yeah, that's fine. Because red's only tied to VBus on one of these 2 sides, but it doesn't matter. Well, actually, that side should be the input. So, yeah, the red side should be labeled, well, the input or the load, depending on whether I'm trying to measure it at the input of the load. Because if I'm charging a battery, I actually want to measure it at the load. So anyway, this side with the red wire is the side with the voltage monitoring. And that really only makes us measure the voltage before it goes through this current loop as opposed to after, which will obviate the current shunt that's in here. So probably a better idea. But for the scale and the accuracy and precision I'm talking about for my measurements, not really going to be critical. Now make sure there's nothing sharp. I think none of these pins are terribly sharp because I'm going to heat shrink this. But one other thing I was considering is just if I do want to run data through this, it's obviously not ideal with these long parallel pins anyway. I was thinking I might as well shield it. So my plan is first to wrap it in electrical tape a couple of times over to make sure nothing pokes into the copper tape. And then I just got to get from the shield to the copper tape, which I guess I'll need a little wire coming through there. Let me get a smaller gauge wire though. So I've got this just real thin piece of wire, just enough to create continuity to the shield. And I'm just going to take it off one of the two shield pins on this board. Actually, I can go even shorter than that. And you know what, I'll make some use of this cheap electrical tape, just because when I put multiple layers of tape, I generally like to use different colors just so I can see where they're overlapping or not easily. And if the tape gets damaged, I could see the color beneath. Oh, you know what I should do is pick up where I was leaving off last night. Because I did a basic continuity test, but let me just make sure that we got current flow. Nothing shorting out over here other than these two, which should be shorted out. And it shows charging here, and the USB-C power supply is at 20 volts, which means that it did negotiate correctly. So we at least have enough lines with continuity for that to happen. And nothing's catastrophically shorted out. You know what, I'm going to throw, just for belt and suspenders, I'm going to throw a little Captain tape on there, just because that might resist poke-throughs differently than the electrical tape. Doesn't have to be neat, just has to cover all the pins. And I'm just going to eyeball it. Oh man, this is really thin tape, so it's getting quite crinkled. I mean, it doesn't have to look pretty to do the job. That's for sure. And then just to try to solder onto this, because of course copper tape will sink the heat away real quick. So I'm not even sure I'll be able to solder, but what I'm going to do is bring the shield wire around the back here and just over to this little piece of tape I have hanging out. And I'm going to see if I can get some solder onto the very edge of that tape where it's a little thinner and won't quite sink the heat away as fast. I just want to see if I can even get a little bit of solder to stick to that. Oh yeah. Not a problem. And then just tin the end-ish of this lead as best as possible. And then hopefully without tearing the tape, if I have to leave a bit of the manual in this, I will, but there we go. And now I will yeah, good. And then just fold that down the side. And then even if that solder joint comes loose, that tape tears, you should still get contact along here from the heat shrink tubing pressing down on it. And then might as well meter it. We should have continuity between this shield and the copper. This shield and the copper tape. Yep. Then now the copper tape, I can see easily it's not anywhere near the actual data and voltage pins on that connector, but I'm just going to push it down right there so it doesn't want to migrate. Now I hope I didn't make this too fat now, because I checked it for the heat shrink tubing diameter earlier and it would fit, but it won't fit over this side because there's these two ears on it, which I guess I could have actually cut off, but you know what, that's fine. So I'll put it in from the cable end. And this is the biggest, no, I think I might have a larger diameter. So let me see. If I can get this on there though, all the better. Ah, no, it's not really going to get all the way on there. Okay, one moment. Yeah, I don't think I have any super diameter heat shrink anywhere else. Well, that's a shame, but not the end of the world. Rather than purple heat shrink, we'll use magenta-ish tape, and this is Scotch tape. Well, it's not what I guess Americans call Scotch tape, which is Scotch magic tape. This is Scotch electrical tape, obviously, but potato. You know what I'm going to do? I'm going to use the heat shrink actually on the bottom, because it will go up about that far. It definitely won't get over this shield wire that's bumped down the side. So I'll get it up that far because that'll just help to sort of corral these ends as well. And I might put a smaller, for strain relief, I'm going to put a smaller piece of heat shrink. Not that it's good strain relief, but I'll put a smaller piece of heat shrink just around the wires at the bottom. I was kind of feeling yellow for that purpose. The only thing I'm not liking is that the inner diameter, or the minimum diameter, of this purple tubing is bigger than the wiring and the yellow tubing. So what I'm going to do is, once this cools a little bit and I can get another heat shrink, I'm just going to then sleeve over this. A little redundant, obviously, but that'll help sort of bring it all together. I guess I could use a piece of adhesive line and just go through it from here to here, and that should really hold everything in. Yeah, I'm going to do that. So a while ago, I wanted adhesive line heat shrink for a different project, so I bought this off Amazon, and complete lie. This is not actually adhesive lined. I left the label on the box just so I remember. It's stupid, but I remember that this box of adhesive line is not actually adhesive line, but this way I know which heat shrink it is, because it's actually decent heat shrink tubing. It's just not adhesive. This does have some gummy adhesive that, you know, splooges out everywhere. So I think if I need to go over both of those, that should do the trick. And I don't want the full length, but I do want to catch, yeah. And this stuff's also a little thicker, a little heavier duty than I would like for this type of project, but it should be okay. And that should be cool enough, because if I didn't let this cool a little bit and I tried to slide heat shrink tubing over this tubing, this might constrict from the heat as I'm trying to slide it up. And in fact, I hope this adhesive doesn't activate at low temperatures, because it might still be warm enough for that. It's not going to be warm enough to shrink the heat shrink, but this might not be a large enough diameter even. No, it's not. Now, hopefully, this will shrink down to the correct diameter. Otherwise, I'm just going to have the same problem all over again. Yeah, that'll be fine. And I do want to cut it down, though, a little bit. But this time I should measure before I cut, right? Bob Vila and Norm Abrams would be appalled at what I do down here. All right. There we go. Oh yeah, that'll shrink down tight enough. And yeah, you can see the adhesive squeezing out both ends. And I chickened out putting the adhesive on the wires. I mean, that would have given a little strain relief to them, but they're compacted and they're pretty tight. The reason I say chickened out is because if I ever want to take this apart again, if the adhesive's on the wires, that could make it really tricky. Now I can just slice the heat shrink off. Anyway, it's not the prettiest thing, obviously. Don't need to tell you that. But should work for the application that I have planned. So then for these two wires, I've got these ring connectors, and they have heat shrink tubing built into them, adhesive line heat shrink tubing actually. So they really help to grip the cable and keep it in place. And they're just crimp type, so it's no big issue to make these connections. And this is specifically made for the insulated connectors. That's why I have this marked. And there we go. Even blue, color coordinated. Then on the ends of these are going to go banana plugs. Banana plugs. Do 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 do. Do 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 do. I'm not using shrouded. I have shrouded banana plugs, but just for versatility, if I want to connect this to something else, because This device does have shrouded banana jacks, so we could do that. But in case I want to one day connect this to a different piece of equipment, you know, just like everybody else, there's plenty of times I forget to slide these on first. Or slide them on backwards, I guess. And now these do have screws, but I actually prefer to solder them in. I'll screw them first and then solder them, just belt and suspenders type stuff. And on these we really don't have to take much insulation off. And I will tin it. Now you shouldn't tin wire if you're using screw terminals. You should either just twist it and put it on there or use crimps, like crimp sleeves. But in this case, because I'm going to be soldering it as well as screwing it, just for redundancy, it's really the solder that's going to be doing the job, but the screw is going to help to keep this from popping out while I wait for this to heat up, because obviously it's a lot of metal right there to get a decent solder joint. And of course, it'll form a big solder plug inside the back of that connector, which then the screw will physically hold on to, even if the screw loosens up as the solder moves over time, as people say it does. Not that I don't believe that, it's just I've never personally verified that to have happened. But so even if the screw's connection to the wire gets compromised, the screw will at least be embedded in the solder plug in the back of the connector. In order to even get this in, you really that's why I don't like these connectors. Are a little fiddly, because in order to, when you're working with a thicker gauge wire like this, in order to get the wire in, you pretty much have to take the screw out, and there's only like one thread on this metal piece that actually grabs the screw. So, and there's a little nubbin on the end of the screw, so that's why it won't. Well, after all that yammering about screws, I think this wire is actually too thick to even get it started. And you know, to be fair, if I hadn't tinned the wire, this probably wouldn't be an issue. Yeah, it really does not want to get in there. All right, I'm just going to solder it then. And what I do need is my old-fashioned helping hands. Actually, you know what? Now that I think about it, I never tried it with these connectors before. I'm moving the heat shrink boxes out from behind this, because what I'm going to do is blast some hot air on it for a minute or two, just to get it preheated as much as possible, so the soldering iron doesn't have to do as much work. I wonder if, I don't think it'll get hot enough to actually melt the solder with just the heat gun, right? Oh, it will. Ooh. Okay. Well, that's nice. So can I just get like a little pot of solder going in there? Yeah. Oh, this is an interesting technique. Never done this before. And I just gotta make sure the wire gets hot enough that the solder, well, we should see it start wicking back in. Yep. That's what we're seeing. And the only problem is I kind of have to leave the wire to its own devices and then take the heat away, and now I got to let that whole thing cool enough for the solder to solidify. That was actually really cool. I'm glad that worked. I'm going to leave, well, yeah, I don't want to move it around until the solder's hardened. And it looks like, yeah, it got a pretty good fill there. That screw hole got filled with solder, and I don't think you could see it. I'm going to set up another angle for the red one, because what happened was actually pretty cool. Since I filled that connector with solder, when I jammed the wire in, some solder pushed out of that screw hole, as one would expect. But then as it heated and the solder on the wire melted, the solder started wicking into the wire, and you could see that blob recede back into the connector. So that was cool. And I'm going to omit the screw, because I like the fact that a little bead of solder comes out the side as like a reserve amount of solder that gets sucked back in. Because I realized if I had the screw in there and I filled it up with solder, I would have to keep filling it as the wire started wicking in the solder. Otherwise, it would actually, the wire might suck up all the solder and leave very little to make the connection itself. Oh yeah, this heat gun's at max, and it says 990 degrees Fahrenheit. So yeah, I don't know if that's measured just at the very tip or that's measured at the heating element. I don't know what that spec really refers to, but yeah, that's hot. And not in the Paris Hilton way. Actually, I think I can lock this on, and then now I got both my hands free. And it should, I guess, be hot enough right now. Yeah. It is. Let's see, I bet it'll just, now that I have the close-up on it, you know it's not going to work right. Oh, and I need to get this on the other side for camera purposes. So now if I dunk that in there, and then you saw the bubble come out, and now the bubble's receding. I think it's actually hot enough that it's burning that insulation a little bit. Yeah, the insulation's looking a little crispified. I might have, probably should have taken the heat gun away just a couple of seconds sooner. But again, I'm just working out this technique for the first time. And then, let me see if I can get that camera in there. Okay, I'm sorry for the shaky cam, but you can see the solder really just came right up to the top there. At least I think you can tell. It's always hard to judge on camera with all the reflections going on. And there's the solder right at the screw hole. Well, that's still, I'll let that cool a little more, but the other thing, and yeah, that's a real solid connection. The other thing about these connectors, which as with so many things I just bought off Amazon only because it's the quickest place delivery-wise. I'm not even a fan of Amazon anymore, but there you go. The other thing about these connectors is if the screw is in there, and even if you don't pre-tin it and you get the screw down as far as it can go, if you're still using a thick gauge wire, the problem is the screw stays a little proud there, and it can be hard to get the connector over the screw sometimes. This is fairly malleable, this jacket, whatever it is, sleeve, and then it kind of just slides over and snaps in. I like these banana plugs well enough, and yeah, the insulation's fine. I mean, it didn't melt or anything. I think it just started burning at the bottom here a tiny bit. It just started smoking, but that's going to be hidden. It's not even damaged, but that's going to be hidden by the connector's jacket anyway. I keep calling it a jacket. I don't know what is the sleeve. It's weird. I don't know what the proper term for this rubbery thing that goes around the connector is, and I've used a million of them. But yeah, there we go. And I didn't check. Yeah, that's tight. All right, the only thing remaining, I guess, is to actually test this out. I can't put this instrument on its face because it has knobs and stuff that stick out. So hopefully it's obvious which connectors go where. We got the red and the black for voltage monitoring, and then this is just kind of going to be a little bit of a hassle. I wanted to use ring connectors because with spade connectors, especially on these kind of binding posts, I'm always afraid they'll come out. You know, like especially with this kind of setup, because I might accidentally, tug in this wire a tiny bit, and that could, if this isn't really cranked down tight, a spade connector can pop out of these. I've found this out the hard way, by the way. Let me just route that sideways so that I can put this on the desk. So, hence the ring connectors, because this is in the back of if this was in the front of the instrument, like most of my electronic loads, I'd be less worried about it because I could easily see if one of these connections came loose. But since it's in the back of the instrument, if, let's just say, the device under test stops receiving power, it's one more thing in the troubleshooting chain, and I might forget to check it, So, there we go. We got that wired up to that. And, yeah, I mean, I left the wires long enough so that this can be in front of the machine. Bring in one of the exact batteries I was trying to test. Bring in my USB-C power supply and USB-C cables, one of which is way longer than it needs to be, but that's okay. Plug power into the instrument. It's a shame I used two white wires because it would be easier to tell which is which if I didn't do that, but let's gloss over that for now, and we kind of know what's happening, I hope. Oop. USB connector, and now this should start charging right away because we do have a through path on the current, and it is charging, so that's cool. It's at 96% though, so I'm going to unplug it because I don't want it to hit 100 because then it'll stop charging and we won't see anything. And right now this is set to measure watt hours. And oh, by the way, it can also do amp hours as well, which could be relevant for testing batteries. But I'm going to put it back on meter mode for now because we'll get the voltage, the power in watts, the amps, and the power factor, which should be unity for DC. Then we plug the battery in. And at first start at 5 volts, then negotiate up to 20. well, actually 19 point, for some reason that USB power supply puts out 19.7 volts. I don't think that's strictly, oh, it dumped down to 15. That might be because it's approaching end of charge. Now, and I have the polarity on the current reversed. I may label one side of this as in and one side as out, and then likewise label those two current connectors, the two ring connectors. But it doesn't matter if it's negative or positive, it's still 25 watts being consumed. It's just showing whether it's flowing this way or this way. And then we can go to integrator function and start. Oh, this is showing watt plus. We got to do negative. Okay. Because this will also sum if you have power flowing in two different directions. Like if I were to charge a battery through this and then discharge the battery through this, it should, well, ideally it should measure 0 watt hours total if I went to here. But of course there'd be losses in the system, so it probably would use more power either charging or discharging, probably charging. So you can see the difference between those two, I guess, but that's not really germane for what I'm trying to do. I mean, I could look, for this purpose, I could look at the sum of it just the same. That value will always be the same as long as current's flowing in just one direction. And it is on the scale of milliwatt hours right now, by the way, as you can see. So it's not used 530 watt hours so far. And if we go back to meter mode, so this is at 14.7 volts right now, and 1.75 amps, call it. And yeah, it is showing unity power factor because it's DC. I wasn't sure if it would show unity or just show like NA or something. But this other battery, it is at empty, so this will probably take a bit more power. Very dim display, but it is flashing it at 0%. And this is probably going to sit at 20 volts-ish. And you can see now it's consuming 2.5 amps at a higher voltage than the other one, so higher wattage. So this is consuming a lot more power right now, which makes sense if it's early in its charge cycle. And then this one's, well, actually I didn't reset it between them, but this one's going to consume watt hours a lot faster, because obviously it's pulling more wattage. So this number is just going to fly right up. Oh, better unplug this because I actually want this to be discharged right now because I want to measure its total charge power. But yeah, so that is the really ugly looking interface thing for this BK Precision 5335B, although this could be used for a lot of applications, which is why I wanted to make it general with just banana plugs and ring connectors anyway, because now I can use this with any piece of equipment or pieces of equipment. That is cool, I guess. Shielding isn't perfect. I wouldn't use this for like high-speed data, I suppose. I mean, I could try. But yeah, is what it is. Should be functional. Should be relatively sturdy. I mean, I'm not going to go throwing it around the room, but I'm proud enough of it. You know what I mean? It's like, that'll do. That'll do. Anyway, thanks for watching this ramble. Obviously, the video is longer than I thought it was going to be. That's always the case. And I'll see you next time.